And I'm Angelica C. Anthony.
Welcome to Module 4 Lesson 2, which is the WILCOXON Rank Sum Test.
Hello future researcher, in this lesson we will be using WILCOXON Rank Sum Test and testing hypothesis, in which WILCOXON test consider differences in magnitude by using ranks. To begin with, let's have first our objectives. To test hypothesis using the WILCOXON Rank Sum Test. And now, let's proceed to our discussion. The WILCOXON Rank Sum Test. The sign test does not consider the magnitude of the data. For example, whether a value is 1 point or 100 points below the median, it will receive a negative sign. And when you compare values in the pre-test or post-test situation, the magnitude of the differences is not considered. The WILCOXON test considered differences in magnitude by using ranks.
In the WILCOXON test, the values of the data for both samples are combined and then ranked. If the null hypothesis is true, meaning that there is no difference in the population distributions, then the values in each sample should be ranked approximately the same. Therefore, when the ranks are summed for each sample, the sums should be approximately equal and the null hypothesis will not be rejected. If there is a large difference in the sums of the ranks, then the distributions are not identical and the null hypothesis will be rejected.
The first test to be considered is the WILCOXON Rank Sum Test for independent samples. For this test, both sample sizes must be greater than or equal to 10. The formulas needed for the test are given next.
As you can see, this is the formula for the WILCOXON Rank Sum Test when samples are independent, in which the R is the sum of ranks for smaller sample size. N sub 1 is the smaller of sample sizes, and N sub 2 is the larger of sample sizes. N sub 1 is greater than or equal to 10, and also N sub 2 is greater than or equal to 10. For better understanding, we have here an example. Times to compute an obstacle course. 2 independent samples of Army and Marine recruits are selected. At the time in minute it takes each recruit to complete an obstacle course is recorded, as shown in the table. At alpha equals 0.05, is there a difference in the times it takes the recruits to complete the course? So now here is the table. An Army and Marines. So here, the Army got 15, 18, 16, 17, 13, 22, 24, 17, 19, 21, 26, 28. And the Marines have 14, 9, 16, 19, 10, 12, 11, 8, 15, 18, and 25. So now, in order to have the mean equals, just add the Army and Marines. So, and divide it by 2, 4, 6, 8, 10, 12. We have here 19.67, and the Marines have 14.27. Solution, we have a step-by-step process.
Step 1. State the hypothesis and identify the claim. Null hypothesis. There is no difference in the times it takes the recruits to complete the obstacle course. Alternative hypothesis. There is a difference in the times it takes the recruits to complete the obstacle course or the claim.
After we state the hypothesis and identify the claim, let's proceed to step 2. Find the critical value. Since alpha is equals to 0.05 and this test is a two-tailed test, use the z-value of positive 1.96 and negative 1.96. Have here a video clip on how to solve or find the positive 1.96 and negative 1.96 using z-table.
0.05, and we split that evenly into the two tails, putting an area of 0.025 in the right tail and an area of 0.025 in the left tail. Now we need to find this value that has an area to the right of 0.025 under the standard normal curve. And we have to remember that the standard normal table that I use gives the area to the left. So the table gives the area to the left. And so when we go to the table, we're going to have to recognize that we need to look up the area to the left. And the area to the left of the value where we need is 0.975. So let's go to the table and find that value. Here's my standard normal table, which gives areas to the left. And we need this area to be 0.975. Areas are found in the body of the table here, so we're going to have to look in here and get as close as we can to 0.975. And right here, we find 0.9750. And so we go to the edges of the table to find 1.96. And so the appropriate Z value is 1.96. And so the table tells me that this value right here is 1.96. Or in other words, Z sub 0.025, the Z value with an area of 0.025 to the right, is 1.96. This value over here, due to symmetry about 0, is minus 1.96. And so our confidence interval will be found by taking the value of the sample mean and adding and subtracting 1.96 times sigma over the square root of n.
So now, let's proceed to step 3. Compute the test value. A. Combine the data from the two samples. Arrange the combined data in order. And rank each value. Be sure to indicate the group. Just like this. Letter B. Sum the ranks of the group with a smaller sample size. Note, if both groups have the same sample size, either one can be used. In this case, the sample size for the Marines is smaller. Then, letter C. Substitute in the formulas to find the test value. Then we have the formula of mean. The value of R is equals to n sub 1 times n sub 1 plus n sub 1 plus 1 over 2, where the n sub 1 is equals to 11 and n sub 2 is equals to 12. So now, 11 times 11 plus 12 plus 1 over 2 is equals to 132. Next, we have a formula of sigma of R is equals to square root of n sub 1 times n sub 2 times n sub 1 plus n sub 2 plus 1 over 12. Then, substitute the value of n sub 1 and n sub 2 equals square root of 11 times 12 times 11 plus 12 plus 1 over 12. Then we have the square root of 264 is equals to 16.2. To find the test value, we have the formula of Z is equals to R minus mean the value of R over sigma of R is equals to 93 minus 132 over 16.2. And the answer is negative 2.41. Next is Step 4. Make the decision. The decision is to reject the null hypothesis since negative 2.41 is less than negative 1.96. Then lastly, we have step 5. Summarize the results. There is enough evidence to support the claim that there is a difference in the times it takes the recruits to complete the course. And that's end of our discussion. I hope you enjoy and learn something today. Goodbye and God bless. Don't forget to like, subscribe, and turn on the notification bell. Bye!